Hi, my name is Lynn Acosta, and today I'm going to be doing a video on a thermistor and the temperature measurement using an NTC type resistive sensor, also known as a thermistor. So today, I'm kind of going to show you the materials I will be using. We will be using jumper wires. I got these 3 long ones and 3 short ones, 2 LED diodes, a 10 kilo ohm resistor, and a thermistor, and Uno R3 controller board, a breadboard, and a USB cable. And this USB cable is because we are going to also do in this video with using Arduino programming. So let's go ahead and begin and putting this together. So first we'll start with the thermistor, and we'll be putting it on the breadboard. And then we will be attaching the 10 kilo ohm resistor. And now we'll be using these jumper wires. So red will go into the voltage, into 5 volts here on your controller board, and this is the analog side and this is the digital side. And then your green is your ground. And then your red is going to go from your resistor, and this will go into your A0. And then now it's time to set up the LEDs. So your green, you can place, remember your negative and your positive. So these can go here. And then now we will be using the long jumper wires to attach these. So your green is going to be, your white is going to be into your 9, which goes into your green. And then your blue is going to be your 8 on the digital side into your red. And then your orange, in this case, will be ground to ground. And now that we set it up, let's go ahead and give it a test run. And we will plug this end of the USB into the controller board. And then now we will attach it to our computer, which has Arduino Programming installed. As you can see here, here's kind of what it looks like. So right now, all the current's going to the red one. But now let's go ahead and jump onto Arduino program and show you what the coding looks like. So this is the Arduino program. This is a coding. This coding was actually given to us by Dr. Khan at the University of Texas at El Paso. And we made minor adjustments depending on the type of temperature settings we would like it, what our limits, upper bound and lower bound limits were. And so here, once you install this code, you actually go up to this check mark and you verify it. And what this does is that it's verifying that the code has no errors and everything is good to run it. And then once you run it and it is done compiling, you actually go to upload. And this actually uploads from the program into the Arduino R3 controller board. And of course, it'll be uploading and it'll verify that everything is done. And then now, let's do a test run. So back to the breadboard. As you can see, here is our green light. And then as you can see, I'm going to show you how this works. So as I hold it, the red light comes on. So what is happening is, the way a thermistor works is that the resistance is very high when the temperature is low. But then as the temperature increases, the resistance decreases with the increase of temperature. So for example, right now, our settings, our upper bounds and lower bounds are at 90 degrees. So if it's less than 90 degrees, it should be green. And then once the temperature increases to greater than 90 degrees, it should turn red. And you can see the lag. So this is pretty much what a resistance does go, and to mention, it does decrease and increase exponentially, the resistance does. So now let's go ahead and go back to the program and show you what it looks like in the program and how it reads it. So here on this program, if you can go up to Tools, and then you could do a serial monitor, and this actually reads it. And as you can see, it starts out at 75, and as I'm holding it, it starts to increase up to 90, 93, and then as I release, it starts to decrease again. And then let's go ahead and show you this on what it looks like on a plot. Again, Tools, Serial Plotter. And then here, as you can see, it is roughly around 70, 74 degrees. And as I hold it, the temperature on the thermistor increases, meaning that the resistance decreases, allowing more current to flow. And as I let go, the temperature is decreasing, allowing the resistance to increase. And then I'll hold it one more time. Now back to the breadboard, I'll explain a little further how this works. So again, right now all the current is going into the green LED because the resistance on the thermistor is really high since the temperature is low, that it is going to the green LED. But as I put my finger on it and causes the temperature to increase, as the resistance decreased, it went all to the red LED. And here's another example of how it works. So for example, if you look at the table, if temperature is greater than 90, the red LED will turn on. If it's not greater than 90, the red LED is off. And here, if the temperature is less than 90 degrees Fahrenheit, the green LED is on. So this is pretty much how a thermistor works. And if you go back to the breadboard, you can kind of see how these tables correlate. Again, less than 90, green LED is on. So thank you for watching. Thank you for watching my video to show you how a thermistor works and how to set up a breadboard and Arduino programming. If you like it, be sure to subscribe. I do these videos all throughout the year. I appreciate it. Thank you.